Welcome to The Explainer. I am so pumped you're joining us today because we're diving deep into the invisible architecture that is literally powering our modern digital world. If you've ever wondered how the digital services we rely on every single day manage to handle just mind-boggling amounts of traffic without, completely crashing and burning, well, you're in the right place. We're going to break down the highly complex but incredibly fascinating world of modern application execution. Let's get right to it.
Okay, let's dive into this. Picture a massive flash sale, or maybe a crazy festive holiday shopping rush. What actually happens under the hood when a million eager users hit buy at the exact same fraction of a second? The system has to process all those financial transactions flawlessly, update a colossal product catalog, and lock in inventory in real time. All of this without breaking a sweat, or worse, freezing up the user's screen.
To make a flawless flash sale happen, an e-commerce platform has some seriously intense system requirements. It needs rock-solid secure user authentication using tokens, lightning-fast product search and filtering, highly personalized recommendations, for things like phone covers or chargers, plus seamless shopping cart management, real-time inventory verification, and incredibly secure payment processing. Now, historically, developers would just cram all these complex functions into one giant unified application. But doing that, it leads to a massive, very dangerous single point of failure. Think about it. If your personalized recommendation engine gets overwhelmed by a sudden traffic spike, the entire website, including your checkout cart, could come crashing down. Total disaster.
So here's our roadmap for today's explainer. We're going to look at the monolithic problem, what microservices actually are, what's going on inside the container, the microservices toolkit, and finally, some real-world superpowers.
Let's kick things off with Section 1, the monolithic problem.
And this brilliantly illustrates the stark contrast between the past and the future of application architecture. On the monolithic side, the old way, everything is tightly coupled together. It's like a giant, tangled ball of yarn. This creates immediate scalability limits, makes maintenance a total nightmare, and, as we just talked about, creates those terrifying single points of failure. But shifting over to the microservices architecture, we see a totally different philosophy. This approach literally breaks that giant application down into independently deployable services. It gives us autonomous execution, complete fault isolation, elastic scalability, and independent deployment. It is a real game changer.
Moving right along to Section 2. What are microservices?
These core characteristics are the real secret sauce behind the architecture's immense resilience. First up, we have single responsibility. Basically, each microservice handles exactly one specific business capability. It does one job and it does it well. Second is independent deployment. This means you can update, say, your payment service without ever touching the product catalog. No ripple effects. Third, they use isolated databases. So services manage their own data storage, which completely prevents that messy tight coupling. And fourth, they are language agnostic. Actually, scratch that, it's more like they just speak whatever language fits best. They can be written in completely different programming languages. Because of this absolute isolation, if your recommendation engine totally crashes, your checkout cart still works perfectly fine. The failure is completely boxed in.
All right, Section 3. Inside the container. Now, what's really interesting about this container concept is how it serves as the standard way to perfectly package your application's code. It bundles the code, the configuration settings, the external dependencies, and the runtime engine all into a single static object. It acts as this completely immutable template. Because it cannot be altered once it's created, it absolutely guarantees that your code is going to deploy consistently anywhere, whether that's sitting locally on a developer's laptop or spun up on a massive, globally distributed cloud server. It just works.
And here's the best part. Unlike those old, heavy virtual machines that require their own bulky, resource-hogging operating systems, containers are wonderfully lightweight. Imagine you have container A, container B, and container C. Maybe one's running a Python app, another a Java app, and the third a C++ app. Well, they are all happily sharing a single host operating system via Docker. They run as perfectly resource-isolated processes. So what does this mean for us? It means you can run dozens, even hundreds of them on the exact same server, saving massive amounts of memory and CPU power while keeping everything strictly, safely independent.
Let's transition over to Section 4, the microservice toolkit.
Let's move on and see how this builds an incredibly robust application lifecycle. First, developers build a container image, firmly packing the code and all its dependencies together. Then, seamless DevOps integration takes over to automate the testing and deployment. Boom, done. Once deployed, the container runs consistently in literally any environment. But the real magic? That's the last step, rapid scaling. Because these containers can start up and terminate in mere seconds, your application can automatically scale to pretty much any size the exact moment traffic spikes. It's beautifully elastic.
Now, the brain managing all of this rapid scaling is a platform you've probably heard of, Kubernetes. It is the ultimate orchestrator. Let's break down its key components real quick. Pods are the basic units that actually run each microservice instance. Think of them as the frontline workers. Deployments constantly monitor the system to maintain the exact desired number of replicas you need at any given time. Ingress acts as a highly efficient traffic cop, routing external web requests smoothly to the exact right places. Then you have config maps and secrets, which safely, securely store sensitive stuff like database passwords and API keys. Now pay special attention to the horizontal pod autoscaler. This thing is incredible. It continuously tracks your workload, and the second a high-traffic flash sale hits, it leaps into action, automatically creating more service instances to handle the surging load. Plus, Kubernetes has self-healing capabilities, so if a pod fails for some reason, no big deal. Kubernetes just automatically restarts it.
However, for all these thousands of separate microservices to act as one single, cohesive application, they have to communicate with each other instantly. That is where a system called gRPC comes into play. It uses advanced protocols to serialize and transmit data incredibly fast. This is what allows a service written in one language, like Java, to instantly and smoothly talk to a service written in a totally different language, like Python. With features like bidirectional streaming and absolutely minimal latency, it ensures that your highly distributed system functions at lightning speed. Literally no communication bottlenecks whatsoever.
Finally, we arrive at Section 5, Real-World Superpowers.
So, the crucial point is that these abstract technical features we've been geeking out over directly translate into massive, real-world business advantages. That fault isolation we discussed, it literally prevents a minor bug from bringing down an entire global system. The portability of containers means companies can deploy their software consistently across huge cloud networks, specialized edge computing devices, or even internal on-premises servers. They achieve highly efficient CPU and memory utilization, and the whole structure completely enables rapid, continuous updates without ever having to take the system offline. It's a total win-win.
To sum it up with a great quote, from secure high-speed banking transactions to AI inference engines, microservices are the invisible architecture powering our digital world. It's not just about e-commerce flash sales, folks. This is the exact same technology that is processing your highly secure finances, facilitating incredibly complex communication in healthcare hospital systems, and powering the most advanced minimal latency AI networks on the planet. It's literally everywhere.
Which leaves us with a final thought to reflect on today. How might your own business operations, or simply that favorite app sitting on your phone right now, be surviving a massive traffic spike at this very second, entirely thanks to this invisible architecture? Think about that brilliant, containerized world silently running your daily digital life. Thank you so much for joining me on this explainer, and keep learning.